Welcome back to part 2 on zeros of a polynomial. I am here with my lovely calculator and a polynomial of degree 3. We need to find all the real zeros of p of x equals x to the third minus 5x squared plus 3x plus 1. And as I've mentioned before, because we have technology at our fingertips, and if your instructor says you get a calculator for a test, it's very important to just graph the polynomial before you freak out too much about the rational zeros theorem. So let's graph it. And if you haven't, you should grab your calculator now, pause the video, and do this with me. Muscle memory is good. Okay, graphing. There's my lovely polynomial. It has 1, 2, 3 real zeros because I can actually see where this polynomial is crossing the x-axis. It's clearly crossing in 3 places. They're not obvious though. So let's zoom in just a little bit. I'm going to change my window from like -2 to +5. Let's graph this again. And it makes it a little easier to see where this polynomial is crossing. It appears to be just slightly to the left of 0, crosses above the x-axis. Then it looks like it crosses at actually 1, and then again at a little over 5. So I'm going to now use P over Q. Notice that P and Q are 1. So I only have the options of plus or minus 1, which is super nice. And I've already looked at my graph. I'll look at it again. It appears that one of the zeros is at 1. So I'm going to use +1 first because I'm making a very educated guess. So listing all my coefficients, 1, -5, 3, and 1. And I'm going to perform synthetic division to prove that my remainder will be 0 and that one of my roots is at, or zeros, is at 1. And then I will have it in quadratic form, which is really going to be awesome. Okay, so 1 times 1 is 1. Put the 1 up above. -5 plus 1 is -4. 1 times -4 is -4. 3 plus -4 is -1. 1 times -1 is -1. 1 plus -1 is 0. Yay! 1 is a 0. So x minus 1 is a factor of the polynomial p of x. Now if I look at what's left below the horizontal line, I have a c, I have an x to the first, and I have an x to the second term. So what's left with my polynomial is x squared minus 4x minus 1. I can now use the quadratic formula to find the other two factors, binomial factors of this polynomial p of x. So I have x is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Simplifying, I have 4 plus or minus the square root of 16 plus 4 all over 2. This is not going to come out super nice. We'll have 4 plus or minus the square root of 20 all over 2. And I can simplify this further. 20 is 4 times 5, and 4 is a perfect square. So I'm going to have x is equal to 4 plus or minus 2 square root of 5 all over 2. That means I can reduce the 2 with the 4, that will give me a 2, and the 2, that will give me a 1. So my 2 additional roots are at 2 plus root 5 and 2 minus root 5. Now if I wanted to write this in factored form again, let me just list what they would be. My factors, they're going to look kind of strange. I'm going to have x minus 1, x minus 2 minus root 5, and x minus 2 plus root 5. These are your exact zeros of the polynomial. This is why it was so hard to tell just looking at the calculator what your actual exact values would be, except for one. One was convenient. And these other two, depending on how your homework is written, you may have to write it as a form like this where you have x minus 2 minus root 5. So very explicit solutions with exact numbers. Or you may be asked to just leave it like this. So you'll have to be careful to talk to your instructor or look at the instructions on your homework to determine which form is being requested. In example 3, we have find the rational zeros of p of x equals 2x to the 4th plus 3x to the 3rd minus 8x squared plus 3x. Well, looking at this, I already know that one of the factors is x. If I factor x out, I will have 2x to the 3rd plus 3x squared minus 8x plus 3. Since I already know that 0 is one of my zeros of the polynomial, I don't have to worry about that one. I need to find the rest of them. So I factored that one out. Now let's list the rest of them. I've got a 2x to the 3rd plus 3x squared minus 8x plus 3. Let's graph that. I'm going to go back to my zoom and do z standard. Let's see if we can see the roots. Oh, okay. So there's a root to the left of 0 and then 2 roots to the right of 0. I'm going to change my window so that I can see from, say, -5 to 3. This will allow me to see a more precise view of those intersections. It looks like one of the points occurs at -3. So we'll give that a try. So I have P equals 3 and Q equals 2. So I have 3 over 2. The factors of 3 are 1 and 3. The factors of 2 are 1 and 2. I have plus or minus 1, plus or minus 3, plus or minus 1, plus or minus 2. So now I'm going to list all my possible roots. I have plus or minus 1 over 1, plus or minus 1 over 2. Got rid of the 1. Those are all my options. Then I have plus or minus 3 over 1 and plus or minus 3 over 2. Now let's look at this graph again, because I know that one of my roots should be at 1, plus or minus 1. Clearly, -1 is not an option. So I'm going to throw out, I'm just going to erase actually. I'm going to erase the negative. So only the positive 1 is an option. Now let's look at this it looks like -3 is an option, but not +3. Clearly there's no +3. So let's write this as -3. Do you see how I'm doing this? I'm showing you the process I'm going through, because if I don't, it's just a disaster. So use your calculator to your advantage. Let's try 1 first. That's an easy one. I'm going to try 1 as a root of this polynomial. I have 2, 3, -8, and 3. Drop the 2 down. 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. -8 plus 5 is -3. 1 times -3 is -3. And hey, look at that. This is why we use our calculators. We got a 0. And so now my quadratic is 2x squared plus 5x minus 3. And so I can use the quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2 times a. So now I'm going to find the other two solutions. This will give me x is equal to -5 plus or minus the square root of 49 over 4. 49 is 7 squared, so we have -5 plus or minus 7 all over 4. And I'll break this up into 2 now. I'll have x equals -5 plus 7 over 4, and I'll also have x equals -5 minus 7 over 4. So my two solutions, remaining solutions, will be -5 plus 7, so 2 over 4. And the other one will be at -5 minus 7, and this, by the way, this reduces. 2 over 4 is 1/2. And then the other one is -12 over 4, which clearly reduces to -3, which was one of my checkpoints. I was going to check that. Okay, so I have found all 3 roots. So if I wanted to rewrite this in factored form, I would say I have an x, and you don't have to put that in parentheses, but I'm just going to for fun. I have a 1, a root of 1 here. I already showed that. So this I can write as x minus 1. And then my remaining two solutions are, or factors, zeros, are going to be x plus 3 from this root. And lastly, I will have 2x minus 1. That's from the x equals 1/2. Now, go ahead and just double check this on your own. I think you'll find that when you set each one of these factors, these binomial factors, equal to 0, you get exactly what my roots were, or zeros. I say both because when you look at a book or when you get another instructor, there's a good chance they will interchange those two words. So give this a try now. You should be able to do most of your homework related to factoring giant polynomials now that you've seen how to do this.